Okay, now we start in on the fun stuff. We are starting in on derivatives, and we start with the power rule. And the power rule is what is often called the shortcut by pre-cal teachers. You bring down the power and you subtract 1 from your power and you have the derivative. So for x cubed, you bring down the power, you subtract 1 from the power, and you have your derivative. Now on this next one, it says the square root of x. You need to remember that the square root of x is the same thing as x to the 1/2. So when you take the derivative, you bring down the power and you subtract 1 from the power. Do, do, do. I sang that song wrong. I was trying to sing the Duracell song. Okay. You know, the little, yeah, I can't sing it. Okay, bring down the power. And y'all are in calculus, right? People often don't subtract right here. And it's really hard for me not to tease you about it. We all do it though, because I do it too. So yes, -4 minus 1 is actually -5. You know that somewhere in your brain. We all have our moments though. So the derivative of a constant, if you really think about it, this is the same as 5 times x to the 0. Because x to the 0 is 1. Hopefully I'm not like teaching you something new. That would be horrifying, right? You'd feel really bad. Okay, so here we bring down the power and multiply it by whatever's left. Yeah, that's just 0. Next one, bring down the power, multiply it by what's in front. We get 15x squared. Beautiful. The derivative of a constant will always be 0. When you take the derivative of a sum, it's the same as the sum of the derivatives. And the derivative of a difference is the same as the difference. I feel like I said the same thing twice. Let me try that again. Or I almost started to say the same thing twice. Okay, the derivative of the difference is the same as the difference of the derivatives. Now, I'm going to rewrite these quickly, and it's going to look to you like I did it magically. I'm going to stop time. Okay, I guess I fast forwarded time. Anyway, so what is happening here is these two pieces of notation, they mean the same thing. But on this second bit over here, it is very clear, it is stated very clearly that you are taking the derivative with respect to x. That's what that piece means, the derivative with respect to x. Okay, we come down below there and we take our derivative and we see that we're looking at the derivative of 4x cubed minus 5x squared plus 7x. Take the power down, multiply it by the constant in front. Can't believe I just did that. I don't need to make a box. 12x squared minus 10x. Take the power down, subtract 1 from the derivative, we get 7. And the derivative of 3 is 0. Okay, next bit. we come over here and we have, oh no, Mr. Bill. That's an old cartoon. I bet you guys don't even know what I'm talking about. I love stuff like that. That I know stuff that you don't know. Nanny, nanny, boo, boo. 5x to the fourth. I'm just dividing. I'm sorry. I forgot to talk about what I was doing. I'm having so much fun just playing with the math. Okay, so 5x to the fifth divided by x is 5x to the fourth minus 3x to the fourth divided by x would give you 3x cubed. And that last one would be plus 4x to the negative 1. And we find the derivative, and we get 20x cubed minus 9x squared plus 4. Now, here we come. Determine the points at which the given function has a horizontal tangent line. Sorry about that weird question on the test. But in any case, a horizontal tangent line occurs when the slope is 0. So notate that somewhere under your eyelids, in your brain. Slope 0. And your derivative is the slope of your tangent line. So you're going to find your derivative here, and you're going to find that your derivative is 3x squared minus 12. And you want to know when that slope is 0, and it becomes, in this case, not always, it becomes a much easier problem. A very easy problem. I don't know why I said easier. And we see that at positive and negative 2, we have a horizontal tangent line. But it does not ask for the x values. It asks for the points. Y'all, I made that mistake. Oh my gosh, I just noticed. Out of the blue, I noticed. Backtrack. Emergency, right there. Negative 1 times 4 is not positive 4, y'all. What? That should be negative 4x to the negative 2. I can't believe I did that. So your real answer here is 20x cubed. I was just trying to make sure you were paying attention. Minus 9x cubed. Squared. Minus 4 over x squared. There we go. Okay, so I'm seeing here that we have a horizontal tangent line at 2, negative 16, and negative 2, positive 16. That is a weird mistake. I don't know how I did that. I know how I did the other one. I'm sleepy. This one, I clearly knew what I was doing and spaced. Okay. Moving right along. We need to know the derivative of the sine of x. And the derivative of the sine of x, which you must memorize for your next quiz, is cosine x. And the derivative of cosine x is negative sine x. Beautiful. Notice the sign changes when you take the derivative of cosine. That is important. Next up, the derivative of 6x squared plus 5 cosine x is 12x minus 5 sine x. And the average rate of change, this is just algebra slope. But the instantaneous rate of change is your derivative. So when we find the average rate of change of f on the interval from 1 to 5, we just use our good old algebra slope formula, f of 5 minus f of 1 all over 5 minus 1, and we get 5 cubed minus 3 times 5 squared plus 4 minus 1 cubed minus 3 times 1 squared plus 4 all over 4, which simplifies when you do the math. Press pause and do the math and check your answer. You should get 13. If you are not pushing pause regularly and liberally as you take notes, you are making a grave mistake. Now we're going to find the instantaneous rate of change of f at x equals 3. And that would be, well, first of all, we need to find the derivative, don't we? F prime of x. Sorry, I'm having trouble fitting everything on the screen. F prime of x would be 3x squared minus 6x. And we are going to look specifically at f prime of 3, which would give us 27 minus 18, which is 9. Okay, next up. Any questions? Oh, I don't see anybody with their hand raised. Ha ha ha. Okay. I'm sorry, I'm full of dumb jokes. Find k so that the function f of x equals x squared plus kx will be tangent to the line y equals 2x minus 9. So we look at this and we want to examine f prime of x. F prime of x is 2x plus k. And we know that this is the slope of this function. We also know that we are looking for this tangent line. So we need the point at which both slopes, 2x plus k, and the other slope, which is 2, the slope of this line is 2, are the same. So we're going to set our slopes equal to each other. We also know that the function f must touch the line 2x minus 9. So we also need to set those two y values equal to each other. Once we set those two functions equal to each other, we are going to replace k with its value. And k's value is 2 minus 2x. Go ahead and solve for x. I replace k with its value. Then I distributed. Then I subtracted 2x from both sides. And I combined like terms. And now I'm all the way down to solving for x. And I get x could be positive or negative 3. Look back at the problem, find k so that the function, it could be positive or negative 3. So I put in positive 3 for x and get negative 4. And I put negative 3 in for x. And I get 8. So there are two different tangent lines, two different possibilities. There's two places where this particular parabola can be tangent to the line y equals 2x minus 9. Actually, I said that wrong, didn't I? There are two different parabolas that are tangent to the line y equals 2x minus 9. And if you graph that on your graphing calculator, you should find that to be true. Y'all have a fabulous day. Take care of yourselves. Get some sleep. Run around the block. Whatever you need to do. Take care. Bye-bye.